Today, on how it's made. Riding mowers. Popcorn. Adjustable beds. And cultured diamonds. When it comes to sitting down on the job, the riding mower is just the vehicle. Animals powered the first ones in England in the 19th century. When motorized mowers came along in the 20th century, they improved on the concept, and we were on our way to greener pastures. Step behind the controls of a riding mower, and you can tame that unruly lawn without even breaking a sweat. The job can be done speedily because a riding mower moves at quite a clip. To make one, a robot delivers a sheet of steel to a die. The die closes with 1,000 tons of force to make a big impression. It shapes it into the part that holds the mowing blades, what's called the mower deck. They transfer the mower decks to a series of presses. They punch holes for the blade attachments and trim the edges. Workers stack the decks for washing. After a treatment with a chemical rust inhibitor, it's time to plunge them into a primer solution. The overhead rack delivers a negative charge to the decks, while the primer has a positive charge, which draws it onto the decks in an even coat. This is called electrostatic painting. They assemble 3 spindles to mowing blades and hoist a mower deck over the blade assemblies. They bolt the head of each blade subassembly to the mower deck. Then they thread rubber belts around pulleys to drive the blades. Assembly continues with gauge wheels, a protective belt casing, and a chute for the cut grass. Next, they clamp a set of steel rails along with some attachments to a welding table. The welding table swings around to an awaiting crew of robots. The robots move in and weld the attachments to the rails. These rails will serve as the framework for the riding mower. The attachments are for the front wheels. Once the rails have been primed, an overhead conveyor takes them into a paint booth. Nozzles spray a powder paint onto the parts for an enamel-like finish. The powder that doesn't stick is recycled. They lower the engine subassembly into position to build the vehicle framework around it. Then bolt the welded and freshly glossed side rails to tubing at the front and back. They attach the footrest to the frame, then install the platform for the seat. They assemble those nifty steering levers, which can be moved into 15 positions. Then they install metal yokes on the front wheels. They slot the yoke's shaft into the frame rail, securing it with a metal snap ring. Now comes the front grille that's vented to protect the engine from overheating. The rear wheels go on next. They're more substantial than the front ones because this is a rear-wheel drive machine. It's time to mount the mower deck and blades onto the vehicle. They position it in front and roll the vehicle over it. The workers activate a lift that elevates the work table to a height that makes it easier for them to secure the mower deck to the framework. They attach the belts on the mower deck to the engine. Monitoring equipment will help them see if this mower's got what it takes to mow down the competition. They put it in gear and check the wheels to confirm that they turn at the correct speed. They adjust the transmission if they're not. They also check the electrical components, and if all systems are go, they complete the assembly. They bolt a side panel in place, followed by the instrument panel. And last comes the seat, complete with armrests. It takes 72 minutes to assemble one of these riding mowers, and it should be good for at least a decade of mowing. Good thing, because its workload is constantly growing. We don't know exactly when popcorn first exploded onto the snack scene, but it was likely thousands of years ago. Popcorn grains dating back nearly 5,600 years have been discovered in caves in New Mexico. And down through the ages, this unique grain just keeps popping up. Nothing says it's showtime like a big bowl of popcorn. This grain has certainly made it big in the entertainment biz. This success story has its roots on the farm, of course. Popcorn is one of 6 types of corn, and it's the only kind that pops. They even breed the popcorn plant to enhance traits like color, taste, and poppability. By fall, the crop is ready to harvest. Peeling back the husks reveals kernels that are smaller and harder than those of other corn. At harvesting, popcorn has a moisture content of 16 to 20%. That's a bit too high, so to bring it down to 14%, they condition the crop in these giant bins, pumping warm air up through it to accelerate the drying. It's a critical step. Popcorn that's too dry may not pop, and if it's too wet, it could spoil when stored. In the factory, a series of oscillating screens sift chunks of cob and broken kernels out of the popcorn. Vacuum pipes pull the finer impurities to a dust collector and suck the larger impurities into a chute. They end up in a waste bin to be discarded or used in animal feed. At this junction, the system funnels the filtered popcorn in one direction and the impurities in another. It's the perfect opportunity to see the difference between the two streams. The purification process continues at the gravity table. Its vibrating action, along with powerful fans, cause the popcorn to rise and float on air. In the process, kernels that are too heavy or too light gravitate away from the center and are shunted aside. The grains in the middle of the mass are the optimal size, but leaving nothing to chance, they go through one more screening. The kernels now head into a very different kind of sorter. Inside, the kernels fly by an electronic eye. It detects remaining debris or defective grains. The machine sends a blast of air to get rid of them. It's time to test a sample of the production run. He pours in 250 grams of kernels along with some oil. As the pot reaches 230 degrees Celsius, the water in the kernels starts to steam. As the pressure builds, those kernels explode and turn inside out. This reveals the starchy part of the kernel and creates a white, fluffy puff. To pass this test, the popcorn has to expand 44.5 times the original volume. The tester loads the popped puffs into a tube with measurements on it, and this batch of popcorn is right on the mark. As you can see, a little bit of popcorn can really go a long way. From a pea-sized kernel to a puffy white treat in a matter of minutes. And although popcorn kernels come in a range of colors, that starchy part that's exposed by popping is always white. Now it's all in the packaging. Maintaining the correct amount of moisture in each kernel is critical. Heat sealing the bag locks in the grains to keep them from drying out on a store shelf. This paper bag, destined for the concession market like movie theaters, is multi-layered. It includes a vapor barrier to control moisture loss. It's taken 6 months to grow this popcorn and a couple of weeks more to process it. But it will all be worth it at snack time, because when these grains explode into a mountain of munchies, there should be enough for the whole gang. Some people enjoy the health benefits that adjustable beds may give. Others like the built-in massage system that gently rocks them to sleep each night. Whatever a person's fancy, adjustable beds can be custom-made to suit their lifestyle in total comfort and class. An adjustable bed helps you sleep with the push of a button. This convenient hand control easily adjusts the head and the foot positions to the contours of your body. It all starts with a quilting machine. It sews foam padding, fire-retardant material, and 2 layers of backing together. Hundreds of thousands of stitches produce a quilted top panel with comfort and style in mind. A machine cuts the panel to a specific bed size. The 4 layers that make up the quilted top panel add luxury and security to the mattress. Meanwhile, another worker prepares the coil spring. He covers it with protective netting. This high-density foam pad comes next. He staples the pad and netting to the coil spring. He puts a bottom cover on the mattress and tucks the foam and the coil spring inside. He turns the mattress over, covers it with netting, then staples it. He puts another high-density foam pad on this side and staples it. Then he lays down the quilted top panel. He holds onto the backing layer and staples the top panel onto the spring. He fills the corners with packing, which gives them a nice, firm edge. Then he sews the mattress together with a tape edge machine that uses binding tape and fire-retardant thread. The tape edge machine makes a perfect seam all the way around and finishes the mattress. Next, a length of steel rod goes into a thread roll machine. Its threaded rollers use hydraulic pressure to transform the rod into a worm screw. They put the worm screw and gear assembly inside a casing. The worm and nylon gears will turn the steel shaft, which raises and lowers the bed. A worker closes the motor casing. Another worker assembles the bed's foundation. He puts flexible nylon hinges between platform boards and staples them in place. He turns the platform over and staples them again. Then he protects the platform with a polyester dust cover. A worker now bolts a steel frame to the platform. He fastens a head motor to one of the metal tubes. To another metal tube, he bolts a foot motor. Finally, he attaches a massage motor. Then a worker covers a support fixture with a cotton bed cover. He puts down a 4-inch high-density foam, then places the fully assembled frame on top. He pulls up the bed cover and upholsters it to the base. The bed is ready for its adjustable bed sheets, but not before a final testing for quality control. Every part must pass a flex test the operator controls. The paper-protected foundation, the steel frame, and all 3 motors must allow the bed to rise and descend with gentle, uninterrupted precision, exactly as it would in the comfort of your own home. All you need now is a bowl of popcorn, a movie, and perhaps a soothing massage. And then it's lights out. Diamonds are a flash of brilliance from Mother Nature. Formed in the Earth's crust by intense heat and pressure, they're prized for their crystalline beauty. But now, Mother Nature has some serious competition because gem-quality diamonds are actually being grown in laboratories. Diamonds grown in labs are dazzling even the skeptics. While lower-grade diamonds have long been grown for industrial use, they were more grit than glitter. But these diamonds have that gem-quality sparkle. They start with a robotic laser. It slices slivers from a chunk of real diamond to produce tiny wafers. They're 5 millimeters wide and a 1/4 millimeter thick. That's about as thin as a human hair. The laser blackens the diamond, so they place it on a steel block for polishing. They rim the wafer with epoxy to keep it from sliding around. This epoxy requires an activator, so they brush it on next. The chemical reaction causes the epoxy to solidify in seconds to firmly secure the sliver on the block. They screw the block to a threaded rod that's attached to a metal arm. They lower the block and its diamond wafer onto a wheel that's swirling with diamond grit. They apply weights to press the diamond wafer into the grit. And as the wheel spins, it creates the necessary friction to polish away the grime. A level confirms the wafer is correctly positioned. Diamonds are the hardest of minerals, and only other diamonds can effectively polish one. The difference is impressive. The diamond wafer has gone from sooty to crystal clear, and now it's ready to grow. A technician places several wafers on a special metal pedestal using a suctioning tool. He arranges them in a uniform pattern, giving them room to expand, because these slivers of diamond are destined for bigger things. He lowers a metal chamber over them. Pumps inject hydrogen and methane gas, and the machine heats them to thousands of degrees Celsius at just the right pressure. The gases form a plasma, which rains onto the diamond wafers and causes them to grow. After just 2 weeks, the diamond slivers have grown into stones at least 10 times the original size. It's quite a transformation. But these diamonds in the rough need a lot more work to really sparkle. They dab epoxy onto the tip of a pointed steel rod called a dop and center the lab-grown diamond on the epoxy-coated tip. Then it's into the laser booth, where the dop is gripped by a robotic arm. It turns it so a laser can trim the lab-grown diamond from all sides. The process exposes the crystal clarity of the gem. A technician checks the quality of the lab-grown diamond with a jeweler's magnifying glass. Then she lowers it into another polishing wheel. It's similar to the one that was used to clean it when it was just a sliver. But this wheel actually contours the grown stone to give it that classic diamond shape. The process brings out all of its glittering facets. It has taken just a couple of weeks to grow this diamond. The process puts geology on fast forward because it takes tens of millions of years for real forces to push real diamonds to the Earth's surface. Only very sophisticated testing can separate the lab-grown diamonds from the mined ones. But since they cost 15% less, you'll notice the difference in your pocketbook.